Welcome back to Sudo Sergeant. In this segment, we'll be demonstrating some essential and basic security configurations for the Raspberry Pi. This will be done on a stock Raspbian install. However, it could be applicable to other single board computers or distributions as well, with slight modifications. Now let's get to the terminal. This is a stock install of Raspbian, and the only account to log into is Pi. What I will do is create a new account. I'll do sudo user add -m, means to create a new home directory, -s is the shell, which will be bin bash, -U means to make the group sergeant, -g means to add a sergeant to the following comma-separated list of groups, and sergeant is the account name. The sergeant home directory is created. We'll also see sergeant in the etc group file. Sergeant also needs a password. That's set with sudo passwd sergeant. That's everything to get an account set up. To log in from Pi, I use su sergeant. At this time, it would be good to take a look at the sudoers file. Modifying the sudoers file requires a special utility, vi sudo. Vi sudo needs to be called with sudo privileges. This file manages how sudo is invoked and what groups or accounts are bestowed with the privileges of sudo. A secure practice is to require an account with sudo privileges to supply a password when calling any program with sudo. Some system administrators like to require anyone logged into the account to also know the root password. In this configuration, I'm only requiring a person to know the passphrase for the account in the sudo group. This is accomplished with placing passwd before all. Continuing on, I'll disable the default account Pi. Su Pi demonstrates that I can log in. So let's cat etc passwd. We see that the shell for Pi is /bin/bash. We want to change it to user sbin no login to disable Pi from logging in. Do this by typing sudo usermod -s/usr/sbin/no login Pi. That will change the Pi login shell. If I cat the password file, we see that the shell has changed. Now let's try to log in as Pi. Okay, the account Pi is still in the system, but it cannot be logged into. There are other ways to disable an account. One is by removing the password or by deleting the account entirely. Back on my local machine, I'm going to create a new key pair. A key pair consists of a public and a private key. I start by issuing the instruction ssh keygen. It'll ask me where to save the key pair. I'm going with the default, even though I already have one there, but it will override it with this new one. I can enter a passphrase, but that's optional. With the key pair generated on my local machine, I need to get the public key to the Raspberry Pi. Currently, Sergeant on the Raspberry Pi doesn't have a .ssh directory, so I'll create it with install-d-m700 ~.//ssh. Oh, now here it is, the .ssh directory. Next, I'll need to copy over the public key from my local machine to the Raspberry Pi. This can be done with ssh-copy-id, the username, at the IP address. To check to see if the keys are added, I'll look at the .ssh directory and look at the authorized keys file. Oh, here it is, the authorized key. Now I'll modify the sshd config file in order to use the ssh key pair. Sudo nano etc sshd_config. Then set challenge response authentication to no, password authentication no, use PAM no. Then I'll save, exit, and restart SSH. I'll try logging in from my local machine under an account that has a different key pair. Permission is denied. But if I switch to the account with the matching key pair, I can indeed log in. Great, this indeed works. It's time to regenerate the host SSH certificates. First, remove the keys with sudo rm-v/etc/ssh/ssh_host_star. Now reconfigure the package. Sudo tpkg-reconfigure, open ssh-server, then restart SSH. I'll go back to my local machine and try to reconnect. It fails. I need to remove the old host key, then add the new key fingerprint. Finally, I'll install fail2ban. Do it with sudo apt-get update and sudo apt-get install fail2ban. Fail2ban is a service that can track failed attempts to the SSH port. And if an IP address fails repeatedly, the IP address can be blocked for a period of time or indefinitely. So now that's installed, let's set it up. So we edit sudo nano etc fail2ban jail.local, and then we add this definition here. this is going to be a banning rule. We do SSH enable equals true, port SSH, filter SSHD, and then we log any failed attempts to var log auth.log. Our ban time will be 900 seconds, which I believe is 15 minutes. Or we could do -1, and that would permanently ban the IP address. And we have a ban action here. That's going to be IP tables, all ports. Ban time, or the find time, that's going to be 900, which is the amount of time in between the number of failed attempts. And that's going to be 15 minutes. And max retry is going to be 3. Okay, now we got that set. We'll start the service. Sudo service failed to ban restart. In this segment, I showed you how to modify the security settings of your Raspberry Pi so you can more securely connect to the network. Now, I know network security is a pretty vast subject. If there's something you think we should go into detail about, please let us know in the comments at element14.com/sudosergeant. And I'll see you on the command line.